Alright, you guys, so what we're going to do next, hopefully it'll be a little bit of a good review of a previous idea. I think this was in 3.5. Once we know the basic shape of a function, we can talk about the transformations that are occurring around with it, and then we can create a quick sketch just based off of those transformations. Alright, so that's what we're going to be doing today. Of course, because we're going to be moving some things around, that means that the domain and ranges might change, especially the range. I don't know if the domain will change too much, because what do we know about exponential functions? They're defined for all values. So it's really more of the range that might change. Because we're moving it up and down, we might end up having an x-intercept somewhere. All kinds of crazy things to happen. The horizontal asymptote will move up or down. Our basic intercept point will move up or down, left or right, whatever the case might be. What I also will do, I'm going to be using transformations to get a quick sketch. Whenever you guys are in doubt, right, you can always fall back on your point plotting. And you can literally start plotting data and get tables of data and then point plot from there. That you can always fall back on that, but you'll hopefully if you just kind of remind yourself about the transformations, you can see how fast it is. You can get a really quick sketch in a very short time, and that's really all I'm after, and it's really all you need. So for the first one, right, when I look at this, if I strip everything away, right, really the only thing that's happening is we're adding 3 to the x value. So we're looking essentially at 2 to the x power. There's your basic function. So we know we're dealing with a growth model. So what I'm going to do, right, is I'm going to basically just sketch, right, in red. I'm going to put it in and there's basically what a growth model looks like, right? So we're looking at 2 to the x. So what's happening here, right? What transformation? Well, you noted that the addition that's occurring is happening to the x. And what we remember, right, when we're adding 3 to x, that means we're actually going to the left 3 units. So what that means is every single data point on this graph, let me go ahead and put it in black, right? So our 0, 1 point is going to be moving over 1, 2, 3 to the left, right? I think we had 1, 2 on the graph. It's going to move over 1, 2, 3 to the left, right? I even think we had 2, 4 on the graph, 1, 2, 3 to the left. And then this behavior is just going to continue to go that way, and that behavior will continue to go that way. All right, and so you can see we actually have a new y-intercept. We'll talk about how to find that later on in our math class. But for now, there's a really quick sketch of what 2 to the x plus 3 is going to look like. It's essentially the graph of 2 to the x shifted to the left 3 units. In terms of its range, it didn't really change much. In terms of its domain, it didn't really change much, right? Domain, we're still defined for everything. And the range, since we just basically shifted it to left and right, the range hasn't changed at all as well. It's still going to get steadily closer to the x-axis, right? So even the horizontal asymptote in the one direction that we have it is still y equals to 0. So not much changed with regard to that type of transformation. So what about the next one, right? When we look at this, if we strip everything out around it, we're basically looking at 3 to the x power, right? So there's our basic function, which we know to be growth, right? So again, a classic growth model goes through 0, 1. This will go through 1, 3. It'll go through 2, 9. But it basically looks like this sketch that I have in red, right? So there's 3 to the x. So what's happening to this 3 to the x? Well, this plus 4 is happening to the entire function. So this means we're actually moving up 4 paces, right, transformation-wise. So going to my black pen, that means that we're going up 1, 2, 3, 4, right, 1, 2, 3, 4. And then what's also going to go up is the x-axis, right? Like I think we had 1/3, right? That point would move up 1, 2, 3, 4. And since the x-axis is serving as a horizontal asymptote, it's also going to go up 1, 2, 3, 4. So we're going to have a new horizontal asymptote, right? That'll be at y equals to 4. And then this graph is just basically going to keep its general shape, right? And in black, there's the graph of 3x plus 4. It's essentially our 3 to the x graph shifted up 4 units. Domain has not changed. It's still negative infinity to infinity, but the range has definitely changed, right? The minimum value now is 4 and up to infinity. So there was definitely a change in our range values because the whole graph, including the horizontal asymptote will shift up with it. So there's basically that graph. And again, you can bust out a calculator and check for yourself that we're right. I'm trusting our math. So the next one, right, what's the basic function that we're looking at here? Well, if we strip the -3 away and that -2, we're essentially looking at 4 to the x. All right, so again, we have another growth model. All right, and it's the growth model of 4 to the x. So we know it's going through 0, 1. We know it's going through 1, 4. It's behaving like that along the negative x-axis and exploding along the positive x-axis. So there's, in red and dot, there's our graph of 4 to the x. What transformations are occurring? Well, we're subtracting 2 from x. So that means we're moving to the right, twice. And then we're subtracting 3 from the entire function. So that means we're moving down 3 spots. So one of the things for sure that's going to move down is the the horizontal asymptote, 1, 2, 3, right? The horizontal asymptote is now going to be y equals to -3. And then this data point, right, is going to move down 1, 2, 3, and it's going to move to the right, 1, 2. Right? This data point will go down 1, 2, 3, and then over 2. And so just mimicking what's going to happen, right? Oops, I'm going to use black here so we can distinguish it. So in black, here is the graph, right, of 4 to the x minus 2 minus 3. It's essentially our original function being shifted down 3 and to the right 2, right? And so there's been a shift in the horizontal asymptote behavior and in the whole graph. So again, the domain is still everything, and the range, right, definitely changed. It's now from -3 to infinity. All right, so once you have those transformations, you can see how it might be a little faster. It is faster, right, once you start to see the transformations, just getting a quick sketch, getting an idea, all right, of what the function looks like. All right, so we're 7 minutes into this, and I got 3 more graphs to do, and we also are going to introduce ourselves to a real famous function. But let me go ahead and start nice and fresh in a new video, and I'll start that in a moment.